So here, these are the little bands for the AKT, which is from the insulin pathway, and AMPK, which is from the non-insulin energy sensing pathway. And suffice it to say that the darker the bands, the higher the activation of this protein is. You have the control here, and this is 1, 6, and 18 hours. It's easy to see that, and this is an example for Sarracenia, the pitcher plant. It's easy to see that it has no effect on the insulin component, but it increases makes the spots darker for this AMP kinase. And this is just a control. The ICAR here is a control, a drug that's known to increase AMP kinase, so we have a positive hit here. We've done this for all of the 8 plants. And so again, this confirms none of them really have any major effect on the insulin pathway. And a lot of them, you see, they're mostly above the dotted line, the control. And if we look at a downstream enzyme, whose activity stays higher longer, well, you see that we have significant activity. And because these enzymes are related, as I told you, to the ATP, and the powerhouses of production of ATP are the mitochondria, then we looked at the function of mitochondria again in test tubes. And there are 2 things that you can do to interfere. And I always give the analogy of a car. If you give some gas and keep the clutch in, you will just turn the engine, burn heat, or generate heat, but the car won't move. Well, this is what's called uncoupling. And this is what happens here. An uncoupler will just increase the amount of oxygen taken up by the mitochondria, but will not produce ATP. The other is the brake. You can, again, give gas, but keep the foot on the brake at the same time. The things will rev up, and the car will want to move, but it won't move. And this is what happens in the second case, which is inhibition of the enzyme that synthesizes the ATP. And so we took every plant and tested this. And for balsam fir here, it's a sort of mixed effect. And so we have here, for the 8 plants, you have like balsam fir is both a brake and a clutch, if you want. And you have some that are more, so this is inhibition, so that's the brake. You have some plants that are just strictly brake, others that are strictly clutch, to give you an idea. So anyways, to make a long story short, one final thing that we did is Hoda Aid in my laboratory, she just graduated with her PhD last summer. She wanted to make sure that it was actually these dump trucks going to the membrane. So she used some markers that can detect these dump trucks when they get to the membrane. And you see that when you give insulin, it doubles the dump trucks, and it's just two ways of looking at the same thing. And then we have one plant, and as an example here, and you see that it's just as powerful as the insulin in putting the glucose transporters to the membrane. So our working hypothesis is that a lot of these boreal plants act more by either doing this brake or clutch thing on the mitochondria, so lowering the amount of energy, not enough to kill the cells, because if you have, these are like poisons, metabolic poisons, but they seem to be very weak. And we've tested, I didn't show you all the data, but we've tested that they are not toxic in that sense, and they are not. But enough to stimulate this pathway. This is the insulin-independent pathway, and then move the glucose transporters to the membrane. So that was for the mechanism of action. I want to finish with 2 case studies of animal studies with 2 of the plants. One is called W7, the other AD01. So this is done by Despina Harbilas, a graduate student in my lab, with Antoine and Diane, 2 technicians. And one of the tests that we were, remember I told you that we can look at fat cells and how they develop in a Petri dish. So what we're measuring here is how much fat is in the cells. And if you stimulate them with these thiolizidine-dione drugs like rosiglitazone that I mentioned, you increase the amount of development of fat or accumulation of fat by about 6-fold. So we were looking, and this increases the sensitivity to insulin. It's one of the ways, it's one of the anti-diabetic drugs. So we were looking for plants that would do this, and we did find some of them, including AD01 that I will talk about in a moment. But look at these 3. We were surprised to see that some of them were actually suppressing the development of these fat cells in the Petri dish. This gave us the idea that maybe there was some anti-obesity effects that could happen also. So this is what Despina did. Then she took the same diabetes-induced obesity model, so the little fat mice that I showed you. This is what the little black mouse looks like. This is its body weight over the days or the weeks that I showed you. And this is what the fat mouse looks like. So you see it's more than double the weight of its lean friend. And look at what happens when you give these plants, forget about AD02, but concentrate on W7. You see that it's almost half, or well, a good third less weight gain over these. This was in prevention, so this was given at the same time as the high-fat diet. So over 8 weeks, they gained almost a third less weight on this. And this is the amount of food that the animals consumed. So of course, at the high dose of this W7, there was a small decrease, but nothing enough to explain this 30% drop in body weight. So this was very interesting. And Despina did another study to look this time at treatment. So as I explained, we let them go for 8 weeks here. So all the animals are at the same point. And then after 8 weeks, then we start the different treatments. And the red ones, they're lost in the background here, but those are the animals, the fat animals, and the black ones are the lean animals. So you see they still keep, it's plateauing off, which is normal. But look at this light blue line. It's hard to see, but even in the face, they're continuing to take this high-fat diet, and they keep eating it as much as the other animals. Okay, there's a small trend for the light blue line to be a bit lower, but this is not statistically significant. Despite this, the animals fed with this W7 plant can start reversing the obesity. So this is very interesting. And actually, when I present this, a lot of the community members said, I want to have some of this plant. OK, so that was W7. Let me give you another example of AD01. So remember, I showed you this was one of the plants that was increasing the production of fat. So this is the good fat. It's the good effect, which increases the sensitivity to insulin. So now I'll give you an example of the fractionation that I mentioned to you, how we identify some of the active principles. So this is the work of Miriam Ushfun in my laboratory, a master's student that just finished, and Jose Antonio Guerrero, a postdoctoral fellow in phytochemistry. So they worked together. What Jose Antonio did is take the leaves of AD01, grind them, extract them with alcohol, as I mentioned. Then he put it on a column, which separates. It's like a sieve, if you want. Okay, and it separates the molecules from size or from different factors. And he got like 9 different fractions. And the crude extract that I showed you, it was increasing, the amount of fats that I showed you was increased 6 times by the drug, while the plant was increasing it about 3 times, 3.3 times, 330%. And then we break it, so we break it up into these little groups of chemicals, and we look, and you see it's all 100, none of them had any much activity. This one is almost the same, 300-fold, 3-fold increase again in the amount of fat in the cells in a Petri dish. So this is then we took this one, and Jose Antonio did some further separation, and he identified 3 compounds. And then Miriam tested each one of these compounds at different concentrations, and just in pharmacology, this looks just like it should do. So this is the example. Again, you see that's the rosiglitazone, so 4 to 5 times the increase. The extract, the crude extract, was about 3 times. Fraction 5 was about 3 times. And you see that each one individually, each of the 3 compounds in this fraction, don't have the same activity as the fraction 5. If we combine all 3, there's a tendency for it to increase. So this tells us that sometimes there needs to be more than one component in the plant acting together. And this is the beauty, as opposed to a drug, which is a single one-entity chemical. Sometimes it's more powerful, but so are its side effects. So we're studying this more and to get a handle on how the plants are working. Of course, we've had some funny reactions. I remember one invited elder from Manitoba said, when I presented these things, said that this was the closest to a panic attack that she had in her life, because at face value, before knowing all the components of the project, she thought we were, desacralizing traditional medicine. But we talked with her, and you'll see also. I'll finish with the ethics, and you'll understand that we are not desacralizing traditional medicine. We're looking at it from one lens, obviously. That there's always limitations. This is just one approach. Then we took the same model again of this AD01 plant and put it through the little fat mouse model. And what we saw is that it was reducing glucose, by 10%, but insulin also. I remember I told you that when you're insulin insensitive, your insulin goes up a lot to get the same activity, the same effect. So this is a good indication that it's on the right path. And also, as I told you, fat accumulation in the liver is really bad for you, and it seems to be improving this. So those were just two examples I wanted to tell you. 2 words on clinical studies, because I'm very happy to report that there have been clinical studies going on in the last year and a half now. This is what we presented to CIHR in the initial project proposal back in 2005. And we were completely disconnected at that point, even though we had been working with the elders for a while. We proposed to do some observational study initially and then go to a randomized placebo-controlled trial like we do with drugs. But when we started discussing this with the elders, a placebo is like a fake drug, so that's unethical for the elders. So we scrapped that. Then we said, okay, well, since these plants were not necessarily used for diabetes, the clinician said, well, we need what's called phase 1 studies, which is giving the drug, or the plants in this case, to healthy individuals just to make sure it doesn't harm them. Okay, we do this with lower level. The Western science does this with new drugs. And the elder said, no, this is like letting someone play with their health. You don't give a medicinal plant to someone who is healthy. So scrap that. So what we ended up with is a very all-inclusive, open, observational study. Of course, in the famous pyramid of evidence, of clinical evidence, it's not so high up as the randomized control trial, but we had this accepted by CIHR because there are guidelines. We use the guidelines of Aboriginal health research, and I'll mention these in a few moments, to argue our case that this would give at least similar outcomes, or would at least give us an indication of both the safety and efficacy of this. So I won't go through all of this, but for those who are interested, these are the inclusion-exclusion criteria. Of course, we're looking a lot for efficacy at all the blood and lipid parameters to see if we can, and of course people are taking the Cree medicine alongside the diabetes drugs. And that's why also we're paying a lot of attention to safety. This, as I said, is done in the Cree Nation of Mistissini with the help of the Cree Health Board, and even the Public Health Agency of Canada are partners in this study. So I want to end with the ethics. Of course, such a project is very sensitive, and actually Jill Torrey, who's the assistant director at the Cree Health Board, one of the assistant directors, actually presented to us a case report where there was one research project on genetics and this project was thought to be a lot more dangerous to the communities. The communities perceived it as much more dangerous than this genetic research because it touches on their indigenous knowledge. So just to give you the legal framework in Canada, of course, as you know, Canada ratified the Convention on Biodiversity, the famous Earth Summit in 1992. So we're bound by that. However, there are no legislations to protect indigenous knowledge in Canada. So there's like a legal void. And intellectual property laws are not exactly well adapted to, and neither are copyright laws. We tried to play with a lot of concepts over the years. However, as I mentioned, the funding agencies such as the CIHR have policies in place, ethical policies in place since 2008, and actually just last fall, I think, the new Tri-Council policies have been put out, and there's a whole section on Aboriginal research. So with the legal councils, both on the university and especially the Cree side, the best approach was to develop a strong agreement, research agreement, to govern the transfer and the use of this indigenous knowledge.